Okay, everybody. So welcome to the Miss Peg. This week we're going to get right into the literal equation homework that is due on Thursday. As always, let's see. It will be due on Thursday, February 13th, if you are following along in my class. If you are not in this class, I will put a link to this worksheet down below if you'd like to practice right along with us. So what we're looking at is literal equations. Let me come over here and pick my pencil. We're looking at literal equations right here. And the difference between regular and literal equations. So regular equations is what we already know to solve for this variable x, where I would box the variable x, see what needs to go. Since this minus 7 needs to go, I'm going to do the opposite, plus 7 on both of the sides. That allows these to be canceled out. We still have a variable x on the left. And now we just have a math problem. 8 plus 7 is 15, very straightforward. So the difference between the regular equation and a literal equation is if you see here, we still have to solve for x, but there's a variable b in here. In fact, a negative b here. So again, I'm going to box the variable just like I did on the first one. But instead of minus 7, we had a minus 7 where we did plus 7 both sides. I notice here that I have a minus b. So it's the same process. See what needs to go, do the opposite to both sides. So I'm going to do minus b and plus b. That's inverse operations. Still have an x equals on the left. But over here is where the difference comes in. On our regular equation, we had 8 plus 7 was 15. But over here, we're left with a plus b. We can't do anything with this because they're not like terms. So actually, x literally equals a plus b. So we could solve for any one of these. We could have solved for the b. In that case, we would have subtracted x both sides and divide out the negative in the end. I'm sure we'll see something like that. So let's take a look at this concept again in a different one, in a different problem. So 4x, box the variable. The 4 and the x are stuck together. That means multiply. So the inverse of that is divide. So I'm going to divide both sides by 4. The 4's cancel out, and I'm left with x equals negative 12 divided by 4, which gives me negative 3. Same type of problem over here and how it looks when you do not have any constants or numbers in there is we still have, all right, box the variable k, see what needs to go, negative 3. I'm going to divide both of these sides by negative 3. These cancel out. I have k equals, and there's nothing I can do here except leave it. K equals m over negative 3. Literally, we just shifted things around to isolate the variable that they asked us to solve for. Okay, let me check over here real fast. Still baking. I have to go pick up a pizza here in a minute, so bear with me. I have to keep checking on that. I'm going to go when it comes out of the oven. I'll just put us on hold for a second and pick it up there in a minute. All right, on to number 3. All right, so number 3 says, so we have a few more steps in this one. They're getting a little bit more, I don't want to say complicated because they're not complicated. We're using the same process over and over again, just a few extra steps. So here I have the variable x that I'm trying to solve for, and this 2 is stuck to it, but remember when they're stuck together like that, we do have to save that for the last step. The other thing now we have is a minus 5. That's where we do want to start. So if we have minus 5, we do the inverse or opposite is plus 5. We do that on both sides, and so these cancel out. Now I'm still left with 2x on the left. And then over here, again, a math problem, 11 plus 5, which is going to give us 16. I'm not finished there, though, so that was the first step, and now I have to go to my second step. So this is a 2-step equation. Now I can go ahead and divide out that 2 in front of the x on both sides. So now I have x equals the answer to 16 divided by 2, which is the number 8. So as you can imagine, and what we've seen so far is that on 3b, when we see a similar problem, when it asks us to solve for b, we're not going to get a nice straight answer like b equals 8 or x equals 8. It's going to literally be b equals everything else shifted around, okay? So here's my variable b. 2 is stuck to it. Hold it for later. And I have to deal with this minus 9. Do the opposite on both sides. These 9s cancel out, and again, I'm left with 2b. Just like I was left with 2x before. Equals, but before I had 2x equals, and I had 11 plus 5 was a number 16. Here, I have d plus 9. So there's nothing that I can do with d plus 9 because they are not like terms. I literally have to write them down as I see them, d plus 9. All right, so that's my first step, just like I had one step here, but then I still had a second step. So I'm going to box the variable b again. Now this time I can deal with that 2 and divide it out. But remember, whatever you do on one side, you have to do to the entire other side. So when we do to both sides, we're just not going to put it under one term. We put it under every single term. Sometimes you're going to see it written like this. The whole thing with 2 underneath it. I don't necessarily make it a habit to write it like that because there are times later it's in our best interest to write it individually under every term. So I put d over 2 plus 9 over 2. And again, we can even simplify this further where we can, we'll leave it like that. So we can say d plus 9 over 2. So I'm going to use the word or right here. Either one of these is an acceptable answer, okay? So I want you to be aware on a test, it can look like either one of those, okay? So moving on, for A, let's see where we're at. Okay, so this pizza's done. I'm going to take a quick ride over there. And so I'm going to put us on pause and I will be right back. Okay, we are back, or at least I am back. Let's go on to number 4. Anyway, I went to go pick up the pizza. It came out really good. It's from some of my students in class who earned some specific points this week. So if you're listening, I'm super proud of you. Good job. I don't know why I'm having a hard time choosing this, but let's do it this way. All right, so on to number 4A.
Down.
So on 4A, it says 1/2 times the product of 4 times x. So here's where my variable x is. This whole term is stuck together, so we have to deal with this 1/2 first. So that looks a little creepy. You may say, I'm not sure what to do. In order to do the opposite, here's the trick. We want to multiply this by the reciprocal. Really, it means we want to divide it, but we don't divide it by itself. But if we had 1/2, let me show you right here. If we had 1/2 divided by 1/2, we'd have to change it to times by its reciprocal in order to do that work. So the rule of thumb is if you see the fraction out front here, or even stuck to the x, you want to times it by its reciprocal because that gives me 2 over 2 would give me 1, which is what I'd be looking for. And so whatever you do to one side, whatever you do to one side, you do to the other side. So we would times the negative 20 also by 2 over 1. This was a 2 over 1. So those cancel out, and I'm left with 4x. And then I have to figure out what is the product of negative 20 over 1 times 2 over 1. So really, when you multiply fractions, you go across the top, across the bottom. So negative 20 times 2 gives me negative 40. Negative 1 times 1 is just 1. I don't have to really record that down here because we are working with whole numbers. So that's how I would finagle my way through that top part of the problem given that 1/2 out front. Here I can very easily box the variable, see what needs to go. This is the common case we see in almost the end of every, like 90% of equations where stuck together, divided out, divide by 4 on both sides, and I get x equals the answer to negative 40 divided by 4. I know my answer will be a negative answer because I have one negative and one positive, and it's division, so that means negative. They're not the same sign. And 40 divided by 4 is 10 because 10 times 4 is 40. So how does that problem look over here? Okay, actually it doesn't look almost anything like it except that we're dividing something out. So let me show you when you have 3 letters put together. There's a very common problem that I'm sure we'll see in class that has to do with distance, rate, and time that is often given in tests that looks like this one right here. So this one's asking me to solve for g, and here's my variable g. So this looks funky because the E and the A are both stuck to the G, just like anything over here, like the 4 was stuck to the X, means divided out. So over here, what's going on originally is multiply, so we're going to divide it out. In this case, because they're all 3 stuck together, we can divide the A and E right out of there on both sides. That's 2 variables in 1 step. All right, then I would be left with G equals, and here there's nothing I can do. I cannot combine anything. None of these are like terms. So it's literally 10 over AE. So there's no really nice formed answer there. It's G equals 10 over AE. All right, moving on. So 5A, straight equation. So box the variable x, and what's the relationship? It says x divided by -8. So I'm going to do the opposite of divide, times by -8 off to the side, and do that on both sides. Okay, these cancel out, x equals, and then here I have 11 times -8 gives me -88. So 11 times 8 is 88, one's a negative, one's a positive, different signs are negative. So what does that look like if I have here, there's no number on the right-hand side like there was before, but same concept, box the variable y, it says y divided by 3, so I'm going to do the opposite, times by 3 on both sides. The 3's cancel out. Y equals, now we have h times 3. Well, that's like up here saying x times 4 or 4x. So we cannot do anything but stick them together. Stuck together, divided out. There's no dividing out here because y is what we were looking to isolate. So you have y equals 3h. All right. So we're clipping through this pretty fast. I think this is 2 pages front and, well, 1 page front and back. I thought I scrolled down and I didn't do a very good job at that. Let me come over here onto the second page. So number 6. I'm going to leave you to do number 6 on your own. So you're going to try number 6, try number 6B, try 7A, try 7B. All right. And I do want to come down to 8A and 8B, and I want to help you with those. Okay. I think you can try some of those other ones for yourself, given the ones that we've already worked on. There we go. All right. So number 8, the first thing I notice is that I have to do distributive property first. So I have this 3 times x and this 3 times -4. Remember, the sign is always in front of the number. So 3 times x is 3x, and 3 times -4 is -12 because they're different signs. So I have 3x minus 12 equals 12. So I want to box the variable and see what needs to go. Well, hold this 3 for last because it's just stuck together. We're going to deal with this minus 12 first. Do the opposite on both sides is plus 12. Those cancel out. I have left 3x equals, here I have 12 plus 12 is 24. So this is our most common step. Stuck together, 3x divided out, divide by that 3 on both sides. X equals the number 8 because 24 divided by 3 is 8. How does that look when we are doing a literal equation? So we have 3 variables here, an x, a p, and a w. So I have 5 times 4x and 5 times positive p. So 5 times 4x is 20x because 5 times 4 is 20, and x comes along for the ride. We can keep those together because using multiply and divide, you can combine terms, multiply and divide terms that have an x without a term that has an x like a constant. You just cannot do that when it's add or subtract. The next thing you have here is 5 times p. So 5 times p, you would just stick them together, 5p. 5 times p, that's literally what that says now. Equals w is what we had left. So that step is done. We've done our distributive property. Now we're back to a step like this where we have 2-step equation left over. Box the variable p because that's the one they're wanting us to solve for. Normally we're used to solving for the x. So don't get fooled. You know, you have to pay attention to the details. What is the question asking you to solve for? So that's why I always say box the variable. It's simple to know what variable to solve for when you only have one in the problem, like over here on 8a has only the variable x. But when you have a problem that has 3 variables in it and sometimes more, you have to be sure which one are they asking you to isolate and box that one. That helps keep your mind focused on what's going on. So this 5 is stuck to that p, save it for later. And here's something we haven't seen just yet. We have 20x, which normally would look like divided out, but we don't do that here because the p is what we're solving for. So just like over on 8a, we would have done minus 12. We had a minus 12 and we would have done plus 12, the opposite. We're going to take this entire term and do the opposite. So if we have 20x, and that's technically positive, we're going to minus 20x on both sides. All right, so that's kind of the creepiest one we've seen so far other than that fraction one. These cancel out. I'm still left with 5p equals. Now, this has a variable w, this term, and this term has a negative, has an x. These cannot be combined. So I'm going to write it just as I see it. W minus 20x. All right. Again, we're still trying to solve for this variable p. The 5 is stuck together. That's our divided out. So on this one, I'm just going to do kind of like what I told you on an earlier problem, put the whole entire term over it, under it. Technically, under the entire term. That's funny. So I have p equals w minus 20x all over the number 5. Or, the way I like to see it personally, but it's never like this in the books, w over 5, because I had that one over 5, minus 20x over 5, or 20 over 5x. There is still another way to divide this out where you can say p equals w over 5, and then go ahead and simplify this. What is 20 divided by 5? Or negative 20 rather divided by 5 is negative 4, and the x is still there. Any one of these options could be seen on a test. That's why it's important to know how each one of these is equivalent, all right? So that's a very big key right there. All right, so I think this may be the last couple problems on the page. Let's see. Perfect. All right, which of the following is equivalent to... All right, so in order to figure out which one is equivalent, you actually just have to do the math. You might be able to do it in your head, but let's see. The first thing I notice is that each answer choice says A equals. So that tells me they're solving for A because we have an A, a B, and an X. So with that, this 7 is stuck together. Hold that for later. Work with this minus 8B. This is the scenario we just saw where we have to add 8B to both sides. All right, those cancel out. I have A equals 10x plus 8b. Okay, I'm sorry, we have a 7 still stuck on here. All right, so we're getting close because I see here a 10x plus 8b, so that's the first choice. I also see here that this is 10x minus 8b, but I don't know for sure should I have a minus. Let's go back and check it out. All right, so we are here. It's we're solving for this a still. In front of the a is a 7, just a regular positive 7. So I want to divide both sides by 7. This 7's cancel out, and I get a equals 10x plus 8b all over the number 7. So it looks like we were right. That answer choice B was our correct answer. The reason why I didn't select it right from the start when I saw this first part was correct was because our answer could possibly change if we had a negative. And if you weren't paying attention, you would see that there'd be a negative there. And this would change this to negative 10x minus 8b all over negative 7. So either way, that one wouldn't have worked out, but you never want to go and assume your answers. It definitely was not answer choice A, which it looks like what they did on answer choice A was when they got to this part, they said that 10x plus 8b together was 18xb. So they tried to add the two constants or coefficients and then add together the x and the b. You cannot do that. They are not like terms. Okay, so B was our choice. And then our last one. So which of the following is equivalent to 4ab plus k equals 13? Well, first thing I notice, every answer choice is k. So they must be isolating the variable k. I like this problem because watch this. The only thing that needs to go is this term here, 4ab. The 4ab is all stuck together, and there is nothing here to divide out. That may be one of your first thoughts, but this is just hanging out there, and it has to get to the other side of the equation. So we're going to do the opposite of the entire term. So if you have 4ab and you want to get it to go away, you want to do minus 4ab. You want to minus it. And you want to do what you do to one side, you want to do on both sides. So now that cancels out. I am left with k, which is what I was looking for. And I cannot combine these because 13 is just a constant. So I'm going to put 13, and then I'm just going to put minus 4ab. This is my final answer, which matches answer choice C. Okay. Again, sometimes people may have said, let me divide out the AB on both sides. That's where they got this. They could have divided, because these look like they're multiplying. They could have divided both sides by 4ab. So that would have been like the next mistake that somebody would have made. And I don't think anyone right now would have made this mistake, but this looks like something that could have happened pretty common, where you did the 13 minus the AB and then tried to divide that 4 out on the end, just out of a little bit of confusion. So that also was not the answer, which led us to answer choice C. So there was a few there for you to carry on and finish on your own. I think that was here on 6A, 6B, 7A, and 7B. But we've done the majority of the page together. Super proud of you for hanging on with me and doing homework. Looks like our video has been about 22 minutes. Take another 8 minutes, finish that homework, and you would have been 30 minutes and done for the week. Again, subscribe. Thank you for watching, and share this video with your friends who you know need help in algebra.